Ireland, but in Ireland as well, we talk about nothing else. So let's find out the answer to that question. The weather extremes, and are we defenseless? Each of our panelists is going to give a very short summary of where they stand on the topic. Then we're going to have a discussion between all of us, and you do get to ask your questions towards the end. We'll have about 15 minutes for you to grill the panel, and also Stefan, if you want him to come back. So let's go along our panel. Please start.
Yes, I want to show you some basic data. I'm a climate scientist, so I do basic research. And one thing that all of you will be aware of is that the global temperature is rising. It has just been announced that 2017 was the second warmest year on record. And indeed, the last 3 years were the 3 warmest years on record. And there were also the first 3 years that were more than 1 degree above the 19th century, the late 19th century average. So that's very relevant for the Paris Climate Agreement, where 195 nations unanimously decided to stop global warming well below 2 degrees, and if possible at 1.5 degrees. Now we've already passed the 1 degree warming mark. This increase in temperature, of course, leads to an increase in heat extremes, and that is very well documented and observed. If you look at this diagram, it shows you what percentage of the land area in any given year in the summer months is 1, 2, or 3 standard deviations above the mean temperature. And so the kind of strong heat would be the orange line, and you see how this is going up. Events, heat that was rare in the 1950s to 1980 is now quite common all the time. And even those 3 standard deviation events that practically never happened before until 1980s are starting to come up. And in some summer months, you have 5% of the land area covered by these tremendous anomalies that will be unprecedented in many cases. One example was the summer 2003, which caused 70,000 casualties in Europe. And for a single event, of course, the journalists always ask us, is this global warming? And you can't really say that easily for a single event, but if you look at the overall statistics, the curve on the left, then it's clear that this is part of a pattern. A similar picture emerges with extreme rain, although the increase is not as strong. Extreme rainfall events are expected to rise because of warmer air being able to hold more moisture, and global analysis of rainfall records does actually show that. So the red curve should normally, in an unchanging climate, kind of be around that blue area, but it has left that around about 1990. So since then, after 1990, we are significantly above what you would expect in an unchanging climate. And the top science journal, Nature, has had the headline about this, that global warming already driving increases in rainfall extremes. And we have witnessed quite a few of those in Germany in the last few years. Now, the third point I want to make is that extreme tropical storms are increasing, and this is a diagram by Kerry Emanuel from MIT, the world's top hurricane expert. And this diagram shows on the bottom axis the strength of the storm. So the strongest ones, category 4 and 5, are on the right, and those have increased the most. They're actually category 5 storms have increased by 400% over the time period since we have satellite data, so we're sure we haven't missed any tropical storms in the past in this area. And if you look at just the list of the strongest storms on record, in practically every ocean basin, the strongest storms have occurred in the last few years, and that was a study done before this current Atlantic hurricane season, where the Hurricane Irma, of course, was the strongest ever observed in the open Atlantic that's outside the Caribbean. So that is my brief summary of how global warming is driving more extreme weather. You can read more here on my blog, an English language blog, Real Climate. German language blog is called Klima Lounge, or you can follow me. And for those that do speak German, the Spektrum der Wissenschaft, which is a kind of German subsidiary of Scientific American, has just published a very nice special magazine about this in November 2017. Thank you.
Dr. Ramsdorf, thank you very much. Dr. Faust.
Yeah, thanks a lot. Yeah, So I would like to go briefly through a couple of points from our statistics. So in 2017, in terms of natural disasters, the overall losses were at 330 billion. So this is the second highest loss year in this regard. Major contribution came, as Stefan already mentioned, from the hurricane season, some 250, more than 200 billion US dollars, the most expensive hurricane season ever. And 93% of all events were weather related, so contributing some 320 billion overall losses. So that means that 2017 was the costliest year ever in terms of global weather disaster. So it fits perfectly to this event here. And reported flood events are increasing over time. We are observing this. In 2017, flood events were almost half of the loss events. And you see the bar on the very right end showing you in blue the insured figure, and the overall height of the bar indicates the overall losses from weather-related events. So I would like briefly go through 3 or 5 it's more 5 practical or really events where we had either too much of water or too little of water. The first is Hurricane Harvey, 1,000-year rainfall events in terms of the rainfall totals in the area around Houston. Yeah, as Stefan already mentioned, and Emmanuel did another study where he showed that these very, very strong rainfalls from hurricanes are already increasing. They have already massively increased over recent decades. And strong hurricanes are also increasing. So risk management perspective is really, one should be aware of this risk along the coastlines, not only in the Gulf of Mexico basin, but also in other areas. And only a small portion of the overall loss burden for private households is currently insured in such a well-developed country, which is a topic on the risk management side. The second example would be South Asian monsoon season, affecting in 2017 between June and October India, Nepal, Bangladesh. Nepal, the Terai Plain, where almost half of the population lives, was to 50% inundated. We have learned the overall loss costs were 3.5 billion, and we have learned from science that the monsoon system is changing in a way is already initially visible, that the variability is going up of rainfalls and also the intensity is going up. So risk management perspective is really improvement of resilient infrastructures pertaining to suitably designed drainage systems, to traffic routes and so on. Flood defense works, early warning capabilities are very important, and risk transfer is already mentioned. The other monsoon example would be China, where we had last year overall losses during the plum rain season, June through July, amounting to 6 billion. In the year before, we had 20 billion, where a lot of large cities affected, Wuhan and Beijing, and the risk of change is similar. So also this East Asian monsoon system has the same features as already explained for South monsoon system. Variability going up, that means also high intensity events on the rise, and management perspective is also very similar. So improvement of resilient infrastructures, flood defense works, capability for early warning. There was much too less alerts and early warning before this happened. Now on the dry side, wildfires, California. So we had a northern event in California, the October fires affecting the wine country north of San Francisco. We had a southern event around Los Angeles in December. The losses from October alone amounted to 10.5 billion overall losses. After a strong, rainy winter 2016-2017, the vegetation immediately responded and again went into a dry situation, accounting for that mass of dry vegetation, which really could be then affected by the fires. Risk management, so we have temperatures going up, evaporation rates going up, so that means the risk will be on the rise in the future, and risk management perspective is really maintaining defensible parameter around the house as the most important one. The last example I would like to show here is the drought in Southern Europe. So since November 2016 or so, we had precipitation deficit in Italy, in middle to southern Italy, elevated temperature levels, a heat wave July through August, also dry and very hot Spain, Portugal, southern France or parts of it, Balkans, Greece, and we had wildfires there. And we already are experiencing that really drought frequency in the Mediterranean is on the rise. So risk management perspective, limiting water use, water recycling, seawater desalination plants, and so on. So these are some concrete materializations of weather extremes in 2007. And with this, I would like to hand over to my colleague.
Dr. Lade.
Yeah, good afternoon, ladies and gentlemen. My name is Markus Lade. I'm with Siemens AG in Nuremberg. I don't show any slides. I'm just giving a brief introduction. I'm heading up a department within Siemens that is supporting the water industry for what we call electrification, automation, and digitalization. Our main areas where we are supporting our customers and projects is desalination plants, water and sewage treatment plants, as well as pumping stations. Beside this typical Siemens portfolio, we are also now more and more engaging into what we call smart water solutions. And I mean, basically this goes into, let's say, this big data topic, what we call in Germany digitalization 4.0. And I mean, you have to imagine that there is a lot of data that we collect into the automation systems, which are basically unused to create value for the customers. And typical examples would probably be leak detection systems. We have a system that provides concepts for optimization of water distribution networks. We are optimizing pump schedules with regard to energy consumption, with regard to avoiding peak times of energy consumptions. One thing that is also relevant for the extreme weather phenomena is our sewage network optimization in order to avoid overspilling of sewage with strong rainfalls into the environment. We are also providing operator training systems in order to optimize and train the operators on the plants. We usually say that roughly 880 million people today are without clean water, and roughly 3.5 million people die because of dirty water. So our message, our aim is to utilize our technology to improve the security of supply for the drinking water. And I mean, with this statement, I would like to close, and I'm looking forward to a very nice panel discussion here.
Dr. Lade, thank you very much indeed. Gerhard Hauber.
Yes, thank you very much. Good afternoon, also from my side. I'm a landscape architect and urban designer. I'm from an interdisciplinary design studio with about 120 people in studios in Germany, but also in Singapore and Beijing. Do we have solutions? I would say yes. I can show you, at least from our profession, from our studio, a few examples. So we know that the weather pattern is changing. We have more volumes to deal with, especially on the water side. Our infrastructures that have been built over a long period of time, but they are mainly underground, and so they are limited. There are solutions that we can learn from nature. Nature is much more dynamic, much more resilient, much more flexible to deal with different kinds of weather and extremes. And we can integrate some aspects or take some of these ideas also into our urban design, our cities. So one example, the cloudburst strategy in Copenhagen. They had several heavy rain events in the city with lots of damages. And then we developed, together with the local engineering company, also a master plan to say, can't we, let's say, use much more the surface also to retain and deal with water? There's plenty of room available, and we developed this holistic master plan over the whole city to say, for example, can't we use the streets? Typically, they are a normal street, but in an extreme rain event, it can also look like this. And what we change is, first of all, we have a holistic master plan for the whole city. Secondly, we also can integrate plantings, green. We can also deal with the heat effect in the summer period. And we don't invest money in the underground where nobody sees it and make this infrastructure bigger. We keep it on the surface where everybody can participate, where we can create nicer cities. And for another example from Singapore, for example, this is a park, typically a park. When there's heavy rain, we can flood the park. And this is not a problem, it's a solution. I think this is also something that we have to tell the people, that we have to accept also floodings on the surface. This can be integrated, this can be managed, and this provides, I think, so much volume and space that can be solutions. And we have a fantastic example also in Germany, Berlin Potsdamer Platz, built 20 years ago. We can store on this water body 3,000 cubic meters of waters that are not going into a drainage system. They are not overflowing the underground system. So there are solutions, and there are clever solutions.
Okay, so I think we've got plenty to talk about and hear a little bit more. Can I just pop along the panel first of all and ask you, from each of your perspectives, what you think the major problem is before we get to those solutions? What would you say?
Well, I think the major problem for humanity is that we are in the middle of this strong global warming, which has been predicted since the 1960s. Actually, 65 was the first official expert panel report to the US president at the time. And had we reacted then, or let's say in the 90s after the Rio summit, when the climate convention, the first one was signed, then we could have very gradually ramped down our emissions and keep this problem under control. But we haven't acted. We have talked and talked and talked, and there's been a multi-$100 million industry working to confuse the public about the issue, and that's why we are at the point where we are now, where really time is running out. The window to still limit global warming to 1.5 degree is falling shut basically as we speak, and if we don't act very fast, we will also miss the chance to limit global warming to 2 degrees, and beyond that, I don't think that these strategies of adaptation will work properly. I think we can't have a manageable adaptation to a warming that is more than 2 degrees if we consider the consequences we already see after 1 degree of warming.
We'll come back to that point that you've just made, about particularly about management, in a few moments' time. Dr. Faust, what is the major problem that, as you would see it?
Stefan already dealt with the, say, mitigation problem, the big problem behind everything. So I would like to then come to the risk management portion. So we have to manage those risks. We have to adapt as good as we can. And from a risk management perspective, so there is a lot of space. So we learn from the IPCC report that so with certain scenarios of future warming, there is some space in many countries for many different economic sectors and so on to really reduce the risk substantially. Mm-hmm. And I made some examples for those flooding events. I think Gerhard showed some approaches. You had this optimization of sewerage. So from my perspective, it's more to better protect private homes, for instance, or also industry plants. To make more resilient, hail-resilient roofs, to improve flood regulation in countries, because China and other countries have shown us that those sort of, say, we have a central approach to reduce the risk given with a certain hazard, like dams or flood protection, then you have a big impact. So there's a lot of prevention we can still do, and one example is definitely environmental technology, all these digitalization-driven things. Yeah.
Okay, well, let's move on to Dr. Markus Lader. What's your main problem, the main stumbling block you would see?
Yeah, first of all, I must say, I mean, I've seldom seen the risk and the global warming topic so condensed in that slides, and I mean I think the problem is obvious. Yeah, I think there needs to be a change of mindset in, let's say, in the populations, with the people, in the governments, and then to really act on it. And I think it will be both on the root causes of the global warming, which I mean obviously I mean, this is try it. But then also, I mean, we need innovations, technology to also, let's say, mitigate the consequences out of the global warming. And I mean, there is, I think, still a lot we can do. I'm also very impressed here by the examples on how to build the cities, on how to do this. And also, I think that we can give a little bit of a contribution to this one. And I think we are also, in that sense, only starting the process rather than being at the end. And I mean, there is still something to come up. And I mean, I think we will need some strong contributions on reducing the consequences which can happen. Yeah.
Okay, and Gerhard Haber, you came up with a few solutions there for us. What are the problems facing someone in your field?
Yeah, I think the biggest problem, I think, is time, because to keep up with the speed of the changing weather, we have solutions, but we know, to rethink or rebuild a city, for example, like Copenhagen, will take 1 generation or something like this, and also, to find holistic solutions. I think also that we not only need to look into cities. We have shown a few examples. We also need to look into landscapes, because in landscapes we can also, protect cities from, for example, from flooding topics, and then also we have to find a solution within the cities. So I think there are solutions. The big problem is to bring all of this in a holistic master plan, and that's where we also lack a lot of power, a lot of political will, and very often also money
as well.
Very simple.
It's what you're saying is it's not a cheap thing to do.
Exactly. And we have seen that the people expect from the cities to deal with a lot of these aspects of the problems. We have cities like Copenhagen who are acting. The master plan is there. The people have to pay more for their water, to build some funds to rebuild the city. And the very important thing is also that this water layer is now part of the planning process. So also within our governments, we need to have this, let's say, this layer of information integrated and also dealt with. Because at the moment we build still a lot, of the infrastructure, old-fashioned, old ways, but we have to change here dramatically.
Let me just ask all of you, and whoever wants can pick it up. I thought it was interesting in the report, the responsibility question. Where does the responsibility lie? Who should sort this out? People want their local authorities to sort it out, but they're also recognizing that all of us as citizens have to have some form of responsibility as well. But are those expectations of our local authorities must sort this out, are they too high, do you think? Who would like to address expectations?
I think they are definitely not too high, because we have to find solutions and we have to act. But certainly the cities, the local government they cannot, let's say, solve this problem, but they are part of the solution. And I think what I also suggest is that we come a little bit away from this, we have a problem, we have to deal with it, there's a lot of damages, costs, and so on. We have also to find the positive aspect. We can rebuild our cities into a much more livable city. And this is also where people find, okay, this is clever investment. Yeah?
So this is where I would like to jump in. So with the question, as far as I got it, so if you say plan for a storage area, kind of excessive rainwater storage, so at the same time, this is a park, or is a new, say, playing ground for children, so something like this. So it's, from my perspective, it's not only motivated by, say, these dire catastrophic outlook, but it's also could be motivated by getting the city more attractive, by getting more park areas into it, which have other function as well at the backside. And this should also be aware and should also be known. But this double aspect, I think, can massively contribute to think also of, as you put it, a more livable, attractive.
I think Dr. Ramsdorff wants to come in on that point there.
Well, actually, on an additional point, because you asked, is it too hard for cities? Are we expecting too much? But they are not alone, because the cities network together, and for example, there's a whole network of climate cities worldwide, and I've spoken at one of their conferences, and so they learn from each other. Cities can try out this and that, and then other cities can benefit from the experience, and I have seen a lot of enthusiasm there at these meetings.
Dr. Lade, a lot of people, I was just looking in the statistics there, 62% of Germans, for instance, want environmental tech to come in and help with disasters. What technically can be done?
Yeah, I mean, we are talking in the moment about Industry 4.0, we are talking about big data technologies, and I think these are innovations that can also be very well applied to the water industry, also to reduce the consequences of, for example, flooding, but then also of lack of water on the other hand side. And I mean, there is basically a twofold effect. The one is to let's say reduce the consequences, but then also we are working on at least providing a contribution to reducing the root causes. Yeah. I mean, you have to imagine that usually water consumption and energy consumption come basically hand in hand. Yeah? In the morning and in the afternoon, you have a peak when people are at home and showering, then energy and water consumption comes together. If you can separate this and then reduce the maximum of energy consumption, the peak of energy consumption, that can already reduce the stress of the energy grids, can also increase the consumption of renewable energies. I think these are technologies that help to support also reducing the global warming. And on the other hand, I mean, that is a little bit visionary. I think that there will come up a lot of more things on the technology side that we are not even aware right now. I mean, we are starting the process. We have some good ideas. And I mean, the whole span will only be seen in the next year and come up, and once it comes into application, yeah, connecting more and more energy grids, water grids, probably trying to steer the consumption a little bit, and so on and so on. I mean, that there will be a much higher flexibility that then gives a lot of benefit to the whole system.
Dr. Feist, what about in terms of predicting risk? Are we getting better at it, do you think? Because obviously that's where the blame lies. Why weren't we told this was going to happen? And what sort of techniques and technologies are you using?
Predicting risk. Predicting risk is, on the one hand side, very simple because we have a, say, ever-increasing wealth situation in many countries, and the big catastrophes, from the perspective of my company, are always happening in those wealthy countries, yeah? So which make the high loss amounts. And so with economic growth, we can really definitely say that those losses will be on the rise further on. But I think you are talking about something else. In terms of, say, individual events or so, perhaps you're alluding to this sort of
events, yeah.
Yeah, I already mentioned that in the Indian monsoon flooding, the alerts or the predictions were missing. And we have construction sites on the one hand side to do better nowcasting or forecasting when there is convective rain involved, so thunderstorm complexes, mesoscale convective complexes, is very hard to really exactly predict. But one could also get better here. And so definitely this is a program. Another thing which we are really bad still, but it's not a deficit of knowledge and technology, it's just a very complex thing, is seasonal forecast. What we know is, for instance, that during an El Nino situation, it's getting dry in eastern Australia, or it's getting very, very wet in northern Peru, or in the western, in the Californian area also. So this sort of thing has to be improved. We are now a little bit better in some regions than climatology. That means to start from a long-term mean as an expectation for this particular climate phase, like an El Nino event. We can do better here. So there's a lot of space also to improve in the weather forecast range. We are already quite good. I should make this point as well. When it comes to, say, forecasting an European windstorm or so this sort of activity, but it's much worse when it comes to flash flood generated from thunderstorms in summer, because we can only say in this area probably there will thunderstorms develop, but we can't say in Braunsbach and Simbach tomorrow there will be a 120 millimeter event. That's not possible.
Dr.
Well,
Ransdorf,
yeah,
and I'd like you also to address maybe the use of digital analysis, maybe sensors, or what sort of things are you doing to predict?
Well, I'm not a weather forecaster, but I would like to point out that, of course, improved weather forecasts and early warning systems are a major, major factor in reducing loss of life from these extreme weather events. And these extreme rains of Harvey that you mentioned, they were forecast days in advance. You know, I remember staring at these maps which forecast amounts of rain that had never before happened in the United States. But it came true. And also, if you think of Hurricane Sandy that hit New York City, almost every hurricane out in the Atlantic there passes on across towards Britain or so, or the polar seas. But Sandy suddenly did a 90-degree turn and banged right into New York City. But we knew days before it happened that this would happen because the forecast models were predicting that. So, and of course, that is digital technology. It depends on really high-resolution computer modeling, which is all the time being improved. And that's where we in climate research also benefit from these models. And of course, it also benefits from all the satellite data that we obtain, where we're now constantly monitoring what's happening on the Earth. And that, of course, is a major thing that we need to continue funding, and not like President Trump is trying to do, cut the funds for the National Oceanographic and Atmospheric Administration, which does these marvelous hurricane forecasts.
So just, I'll move along, Gerhard, in a moment, but just on that point of Trump cutting the funding, what effect will that have?
Well, it will make the forecast capabilities reduced, of course, and it will ultimately hurt the people on the ground if they have a lower quality forecast.
Okay, thank you.
Can I probably add something?
Oh, just on that point as well.
Yeah.
I'll come to you in a second. Yeah.
I mean, many of you have probably used Google Maps to come here and to avoid traffic jams. Yeah. So we are, for example, thinking about, okay, why not use the information of the car that is driving on the street and using the wipers, yeah, and transfer this data to predict where's the weather, where's the strong rain, yeah. I mean, these are very simple examples that are not existing now, but maybe in the future will utilize the intelligence of the cloud, yeah, to have a much better view on what is happening where.
Gerhard Haber, you're nodding away there.
Yeah, I wanted to point on say something about the point of prediction. I think this is extremely important that we get really good in prediction, because we potentially, I mean, here in our Northern Europe climate zone, we are probably not so heavily affected. Yeah? Maybe we can mitigate some of these effects. Southern Europe, it's already more extreme, but we have areas where potentially we as a society, or as a global society, we have probably to think also to do some extreme steps. For example, in Jakarta at the moment, it's discussed if the city can be protected, or if the city has to be rebuilt somewhere else. There is, for example, in New York City, the Big U project, where you build a huge protection wall around Manhattan. But again, can this be also a positive aspect to bring in new livable aspects? How can you use this protection wall? You potentially have to do it, but you can also do something positive. And in San Francisco, in the San Francisco Bay, it's thought about, swimming cities. Is this possible? So there are many options. Maybe in our society, if we have good prediction, we can say, okay, with this city we can, or with this weather conditions, we can mitigate them for the next 20, 30, 40, 50 years. In other areas, we probably have to do really bold steps and maybe do some extreme actions.
There is a difference, though, between building somewhere new with all of these technologies that you were talking about and retrofitting a major city in the world. I mean, that must be almost impossible to do, the retrofitting.
As I said, where does it make sense to retrofit, and where potentially does it make sense to rebuild? Because we know weathers will be extreme. We have maybe more earthquakes and have to build more safe. Stronger winds, how can we protect our buildings against strong winds? I think we have the technology and a lot of knowledge. And but sometimes it's also too easy to say, okay, let's get rid of the old shit and build something new. I think also we have it's also a society that has built up that value, and we also have to kind of protect this. But sometimes we also have to do big dramatic steps, in my opinion. And
What
therefore
about-
prediction is important.
Yeah, and what about limitations of what is out there at the moment to help?
What do you mean?
In terms of just looking at all the solutions that have been given to us here, there's obviously a limitation to what can be done at the moment, considering you were saying that we're almost at the deadline for repairing global warming.
Yeah,
Would that
sure.
worry you?
Well, sure it does, and there are definite limitations. It would be easier to adapt to a new climate, but not so easy to adapt to a climate that will constantly keep changing. So number one point, of course, is to stop further warming so that eventually in the second half of this century you reach a new steady state, albeit at a higher temperature level. But for example, with sea levels won't stop rising for thousands of years because the sea level responds extremely slowly to warming. It's only just starting to rise in response to the 20th century warming. And it will eventually be several meters of global sea level rise when the ice sheets continue to melt, as they will do in a warmer climate. And so that's why the decision, do we keep this city or do we move it, is very difficult, because you might build a wall like these flood barriers that they plan for New York City, but how long will this last? This might buy you 100 years perhaps, and maybe that already makes it worth doing. But in terms of sea level rise, it's difficult to think of a really permanent solution, because it will be such a large rise that goes on over thousands of years in the future.
And in your work, are you constantly changing and having to attain greater things because of the changing climate?
Yes.
Or did you just turn out the same solution each time?
No. It's basically the question of volume, because if when we have started 30 years ago, there was not much talking about changing climate, and then you looked into the past and said, okay, this is an extreme event from the last 100 years or 50 years of information or 20 years. And now we know that there is the future, there will be dramatically more volumes to deal with. And so we also take, so to speak, statistical rain events for the future, and these are constantly changing. So we always have to put into our models, when we calculate, let's say we want to build this property, say, for a 50-year storm event, we always have bigger volumes. And then where do we find solutions that also, can also be paid for? That's also a big question. And how can it be integrated?
Dr. Faust, in terms of, we're just talking money there, in terms of financial cost, and then of course there is loss of life in some of these events as well, but in terms of financial costs, some of the figures are huge, aren't they?
They are definitely financial costs from such loss events, and this might build up some pressure, to respond better. I would like, if I'm allowed to comment on this, also on these limitations or so, because it's also sometimes a matter of psychology. So if we have, for instance, forecasts, hurricane forecasts, the US authorities are sometimes really urged to force people to respond adequately to the approaching hurricane. Apart from the fact that perhaps in case of Irma or so, we did not know exactly which track the hurricane will take. But we have much improved over recent decades in terms of this kind of forecast. This should always be pointed out. So it's what do we do when we know something? Or another example I learned from Germany is after the 2016, say, flash floods and other flash floods, an increasing flash flood situation we have also in summer, not only in winter and spring and in autumn. There are hazard maps coming on, which are produced by really extensive computer simulations and so on. But I have learned from authorities or community representatives that the most effect of those hazard maps, where you can find where will probably debris accumulate, which will be traffic routes, which will then work in a big flash flood event. It will not be inundated, so that, say, sanitation, medical care people and the police also can go. So all this sort of thing. It works most after a catastrophe, or when there is some current event, but not 5 years after or 10 years after anymore. So we have to think about how can we educate, how we can do trainings at schools, for instance, for this sort of community-wise hazard information. So these sort of things, psychology is also very, very important.
Should this have been done, though, not thinking about it now, but thinking about it maybe 20, 30 years ago? Should we be further ahead with these weather problems?
I think it would be very hard to be ahead of, say, the development in terms of the climate or so. We should keep pace with what is already going on. So we are lagging behind already in respect to this. And so hazard maps is a topic. For instance, if you have 120 millimeters in 2 hours, then, okay, flood protection measurements are important, but maybe not any more reliable in such a situation as we had in 2016 in Germany. So then it's very important to save life, and those maps could be really a means to know which location to go to or something like this, but only if we are trained to do so, yeah, if we have the knowledge, and it's not somewhere in the town hall at some desk or so. So it must be known by the population, and we have to think about how can we achieve this. So this is one of the limitations I always think about.
Let's just go along the panel. The question of today's topic is: are we defenseless? Do you think we are?
No, I don't think we are defenseless, because we first of all have lots of options for adapting to a limited warming amount. If we can contain it to well below 2 degrees, then we won't be defenseless. And of course, we still have the chance to stop further warming. And indeed, as I mentioned, that has been unanimously decided after decades of deliberations in the Paris Agreement, and it's a binding treaty, and everybody who's voting or writing about this or so should constantly remind their own government that they signed on to the Paris Agreement and they should implement it.
Are we defenseless?
I don't think so. And I would add to what Stefan already said, that the Paris Agreement has this charming or really attractive feature that its result, whether we will arrive at 2 degrees above pre-industrial or even higher, its result depend on future developments. It's not only written there what should be done, but it's written there that we should plan for more and more ambitious targets, mitigation targets by all the countries. They should increase their ambitions. And they can only increase their ambitions every 5 years or so in this process when societies are motivated to do so, when awareness is risen. So it's a process we all are involved in. And so that's why I think we can do progress. It's not sure, perhaps we will fail, but we can really improve the situation on the greenhouse gas mitigation side. But we are also not defenseless in terms of the already of the existing hazard situation and their change driven by climate change. I think, as I said, there are limitations, but for instance, the insurance industry in the United States, where we are participating in, is doing an industry institute for business and home safety, where we improve prevention. So we put houses in hurricane force winds, looking which construction is most resilient or is most resistant resistant to this sort of strong winds. The same is happening with fire with respect to, say, wildfire, or with hail in terms of better resistant roofs or so. So we can do something on both sides.
So are we defenseless?
I would like to say, as an innovator and also as a scientist, I would say, okay, I'm quite optimistic that we can develop technology and innovations that will really change the game. But as we already discussed, I mean, the awareness must be there, and I mean, really the will to do it. But then I think the adaptation might be possible, and also at least the limitation of the climate change. Yeah.
And your answer to the same question?
I think most of it is already said. Probably I agree to what has been said before, that also how we as a society react, or do we act and not just react, and how do we also accept, for example, because I think we also maybe have to differentiate between the real extreme events. I think we never can really, let's say, protect us from all the really heavy events, but we have to make sure that only, let's say, property is damaged or so, but we save the life of the people. But we really can prevent a lot of the, let's say, the not super extreme events. And there, it's just a matter of action. We have so many fantastic ideas. I know I have explained some of them. There are many out there. There are many solutions on the technology side, on the how we act as a society, how we change our cities. So many solutions.
But it sounds like everyone has to work together. For all of your comments today, really feed into the same message.
This is key. I think this is really key, and this is what we also. We as a studio, we have always, water engineers, landscape architects, urban designers, artists, and everything together. Only with this holistic view, I think we can develop on one hand also a mindset of how we as a society accept also these changes, and secondly also act into change. I think this is only interdisciplinary and in a holistic view possible.
Dr. Ramsdorff, were you surprised by any of the findings in the report, the responses from people? What in particular was worrying them?
No, I wasn't surprised. I thought these were the numbers roughly as I would have expected them. It would be nice to see it maybe across more different countries and compare attitudes in China or Brazil or South Africa, whatever.
Do you think that would change?
Well, I'm sure there will be differences, and I would have been curious to see them.
In terms of the solutions, though, what if you could only do one thing, if you had to put money into one thing that would help, I'm sure you can't help everybody, but would help the majority. Has anyone got an idea what that one thing should be?
Well, I think the concept of doing only one thing is wrong, because you could say the same thing. If you could only do one thing, what do you want to have, fire brigade or ambulance? We have both, of course, because there are various risks, and I don't think there's a lack of money preventing us from being much better prepared and from mitigating climate change. It may be expensive, but not doing it will be much more expensive.
What about the rest of the panel? Were you surprised by any of the figures coming out of the report today?
What I found positive is that 60% of the people think they by themselves can do something, and this is, in my opinion, very positive, because they feel responsible for what's happening, even if their individual, let's say, contribution is very, very small, but they care for the world, and this is, in my opinion, very promising.
And also the concept that it's a local issue as well, where they want the local authorities to deal with it, rather than going to big government, as it were. So local solution for local issues, yeah. Is that what you see as well? Did you hear that when you're...
Well, there was no number what they would have said if they asked whether the national government should become active.
That is true. Maybe we need another survey.
Exactly the same numbers, I think.
If they would be willing to pay for something, yeah.
Comes back to the money. At that point,
most people are actually.
At that point, we're just going to pause in the panel, and because the people on our live stream are now about to leave us. So thank you very much for those on the live stream for being with us, and we hope you enjoyed the panel. And we're now going to throw it open to the floor. So don't all stampede at once, but if you'd like to come to the microphones, you can ask your questions. Please say your name and which organisation you are representing. And also, if you want to address a particular panel